These are the notes for October 26th. That's a Monday. For those of you who were absent and need a little extra help, I went back and I'm putting a voiceover to kind of talk you through this. We've already been looking at parallel lines cut by a transversal. From yesterday, we knew that alternate interior angles are congruent, corresponding angles are congruent, and same side interior angles are supplementary. Today I'm showing you the proof that alternate exterior angles are also congruent. And I already have it worked out. I thought we'd just kind of talk through it. If you'll look at the picture, it shows line L and line M are parallel. They are cut by a transversal. I'm going to label it T. And I've got all the angles numbered. So it says if a transversal intersects two parallel lines, so our given is line L and line M are parallel, then we are to prove that alternate exterior angles are congruent. Angle 1 and angle 7 are alternate exterior. They're on alternate sides of the transversal and on the outsides of the parallel lines. That makes them exterior angles. 2 and 8 are also. And so to prove the theorem, we just have to choose one of those pairs. So I went ahead and chose angle 1 and angle 7. All right, so when we start a proof, normally, at least for now, we're going to start with the given. So our given information is L is parallel to M, and the reason for that is given. Then I looked at the picture and said, okay, I need to work angle 1 and angle 7 into my proof, because that's what I'm trying to prove. So I started with angle 1. Angle 1 is on the top left corner, and we have a corresponding angles postulate that says when lines are parallel, cut by a transversal, corresponding angles are congruent. So I went ahead and introduced angle 1 and stated that it was congruent to angle 5. Since 5 and 7 are vertical angles, we also know that those two are congruent. Reason being, vertical angles are congruent. And if you'll look at the picture, since 1 is congruent to 5 and 5 is congruent to 7, then 1 and 7 must be congruent. And that is the transitive property of congruence. So a pretty short proof. And now since we have proven this theorem, we can use it any way we possibly need to. You all have been assigned a couple of worksheets where you have to calculate some angles. So I thought we'd look at just 2 examples before you try to do the examples or try to do the problems on the worksheet. Maybe by talking through them, we might make it just a little bit easier for you to get through. New picture. You can see by the arrows on lines L and M, those 2 lines are parallel, and the double arrowheads on lines P and Q are showing that those 2 lines are parallel. We are looking for the measures of angle 3, which I'm going to mark with the pink line, and the measure of angle 4. I'm going to be careful not to mark them with the same number of arcs because I don't want anyone to be influenced by that and think that those angles are the same measure. We don't know what their measure is right now. What we do know is we have a 105-degree angle. And so we can just kind of work our way around the picture and find any angles we need to find or can find until we can get to angle 3 and angle 4. All right, so if you stare at this picture with P and Q being parallel, P is parallel to Q, then we know that angle 5 is 105 degrees because it is a corresponding angle with the angle that's given to us. That's corresponding angles. When lines are parallel, cut by a transversal, corresponding angles are congruent. So we know one of those measures. We're looking for 3, and if you look at the picture, angle 3 and angle 5 are a pair of vertical angles. So that means they're the same measure. So we can conclude that the measure of angle 3 is also 105 degrees. So there is one of our angles that we're looking for. Now we need to work our way over to angle 4. So let's see. Let's figure out what we can do with things. If we use lines L and M being parallel, angle 3 and angle 8 are a pair of corresponding angles. And because they are corresponding angles, they are also congruent. So angle 8 is also 105 degrees, which means we can calculate angle 4. Angle 4 and angle 8 are same side interior angles. And one of our theorems says that those angles are supplementary. Meaning that the measure of angle 4 plus the measure of angle 8 equals 180 degrees. We know that angle 8 is 105 degrees. So we can subtract 105 from 180. And it gives us that the measure of angle 4, the other angle that we're looking for, is 75 degrees. I'm sure that you may have seen another way to get there. With all the theorems that we've had, there's quite a few options for working your way around that figure. But you can get there, and this is just one way. We've had plenty of theorems. There's several ways to get around to the same measurements, but you would end up with the same measurements. All right, one more example, and then I think you'll be sitting in a place where you can take off on the assignment. Example 2, we have two lines that are parallel. They're the ones with the arrowheads, and then the other angle, I'm going to label it T. We can call this P and Q. T is the transversal. And it asks us to find the measure of each labeled angle. So we actually have 3 angles that we need to find. We don't have a whole lot of information going here, so what I would suggest you do is write down anything that you know. So let's give this a shot, and we're just going to take some notes. Because y and the 3x plus 23, because they're corresponding angles, we know that those two angles are congruent, which means that their measurements are the same. So I can set them equal to each other. And if we look up on line P, the 2x plus 12 and the y are a linear pair, which means if you add those together, you get 180 degrees. A linear pair, remember what that is, 2 angles that are adjacent and their outside sides form a straight line. Well, take a look at what we have. Since we know that y is 3x plus 23, we can take this value for y and substitute it in for y into our second equation. And it looks like we'll have something that we can solve. 2x plus 12 plus 3x plus 23 equals 180 degrees. We now have an equation with just one variable, and we can solve it. If you'll combine like terms, put your x terms together, that gives us a 5x. Put the constant terms together, the 12 and the 23, that makes 35, equals 180. Subtract the 35 from both sides of the equation, because now we're solving for x. So 5x equals 145. And then divide both sides of that equation by 5. we get x equals 29. Now, we have found x, but that's not what we're looking for. We were asked to find the measure of each labeled angle. So I'm going to take that 29 and substitute it in for x in the 2x plus 12. 2 times 29 is 58. Plus 12, we have a 70-degree angle. And I can label the picture. Since that angle and the y are supplementary, that means the other side is 180 minus 70, or 110 degrees. That's our y. Which means the other angle is also 110. Why is that? Because they're corresponding angles. To double check, though, I am going to put that 29 in for x and do the calculations. Let's see, 3 times 29, 87, plus 23 is 110 degrees. They are the same. It did a check for me. All right, that's it for the examples for today. If you look at those theorems, take a look at the examples, I think it will have you set to do the assignment. As always, if you have questions, be sure to email me.